Hello there. Welcome to my second video about my gear machine project. In this video I'm going to jump in and start disassembling the machine and show you some of how it works. Before we get started, what is this thing? In function, it is basically a small CNC shaping machine. In this type of machine tool, a cutter operates by moving back and forth along a linear path relative to the workpiece. In the case of this machine, that movement is vertical. The cutter assembly also moves horizontally over the workpiece. The workpiece itself is attached to a rotating table. Between these degrees of movement, it is theoretically possible to cut spur and helical gear teeth into the workpiece. The machine has three main electrical and three main mechanical areas. The three main electrical components are an Arduino Uno control board, the motor control board, and the power supply. The three main mechanical subsections, including their respective stepper motors, are the carriage, the rail, and the table. In today's video, the carriage will be the main subject, and we're going to break it open and see what's inside. The rail section of the carriage rides on two 8mm rods clamped down under these wooden blocks. The carriage is propelled by a TR 8x8 lead screw, which couples into one of the NEMA 17 stepper motors. I'm going to speed through the disassembling steps. First, the cables to and from the power supply are disconnected. Next, we remove the high-quality cable management system, leading to the limit switches and stepper motor. As you can see, the entire frame is made of these large hardwood blocks that are bolted together. So to take off the carriage, we have to take off the blocks holding down the rails by removing these nuts. Next, we use an Allen key to loosen the grub screws in the coupling between the motor and the lead screw. And the carriage and rail can be lifted out. The grey 3D printed parts on either end of the rails are spacers to try and keep the rails parallel to each other. The carriage runs on the two rails being carried by 6 linear bearings, which are within the grey pillow blocks on either side of the carriage. They are 3D printed. Here you can see the brass anti-backlash nut attached to the carriage. To get to the carriage, we take off the wood screws holding down the top plug, which is also a 3D printed part. The body of the carriage is a rectangular aluminum extrusion, with some small windows milled into the side. Of course, not forgetting to take the cutter off of its arm. And fumble the parts. This area needs some real development. Finally, by pressing on the bottom of the cutter arm, you can pop the top plug out. Time for more highlights. We'll start with the stepper motor, which is a NEMA 17, a 3D printed coupler, and a 1mm pitch lead screw. Two brass nuts are arranged in such a way to provide anti-backlash. They are mounted in the black bridge section. This is clamped onto the cutter arm by large wood screws. The cutter arm is another 8mm rod. The arm rides through a linear bearing. This is the limit micro switch and its adjustable plunger. Of course, plastic isn't the ideal material for this part, however it's proved adequate for testing so far. And speaking of plastic, clearly I need to reprint this part. I think the cracking was caused by the old ABS filament that I was using. The plug design for the top and the bottom are identical. On this end we have another linear bearing to guide the cutter arm, and a bearing to center the bottom of the lead screw, and a limit micro switch for the travel of the carriage. I'll quickly take off the plug on the other end. We'll speed through this because it's essentially the same process as before. For visual reference, let's put them back together. Okay, that's it on the breakdown of the carriage. I appreciate any comments or questions. Thank you for watching, and hope to see you next time.